This is Math 4150, Exam 1. So for question 1, in order to play the game, I decided to go first so that I could choose one piece of candy. From here, I would then take 4 minus whatever my opponent takes, because we have 30 pieces of candy total, but only 29 Starburst and 1 licorice, and I don't want the licorice. So what I did was I grouped all the Starburst into groups of 4, and I have 7 groups of 4 with 1 left over. So I have 7 groups of 4 Starburst with 1 left over and a piece of licorice. So if I start and I take the 1 piece of candy, I can then manipulate the game so that whatever my opponent takes, I can take 4 minus my opponent. So if my opponent, this looks bad. If my opponent were to take 2 pieces of candy, then I would take 2 next. And then if they were to take 3, I could take 1. If they were to take 4, I could take 1 and then they would go. But then I could still manipulate it to play the game in my favor. That way that they would end up with the licorice at the end of the game. For the second part of the question, if I wanted the licorice, I would add the licorice back in. So instead of having it so that the licorice is out and I would have the 1 piece of candy, I would draw to include the licorice. Drawing, I would include the licorice instead of having it out to the side. And I decided that I would take 2 pieces of candy. So I would then take 2 instead of the 1. This way my group, the amount of groups that I have change. So I would have 5 groups of 5. And at the end, I would have 2 Starburst and the licorice. So my drawing would look like the second one here at the bottom. So if I start with the 2, and that would be the 2 that I take, then I can manipulate the game to play so that I would take 5 minus whatever my opponent takes instead of 4. And then I could end with 2 pieces of Starburst and the licorice so that I would get the licorice at the end because it has to be included in my turn. For question 2, the difference between a place value system and an additive system. So a place value system, each number has a single symbol, whether that be in the Hindu Arabic 1, 2, 3, 4, or so on. While an additive system, there can be multiple symbols for each number. So you would have a group of symbols and then another group of symbols and another group to represent one number instead of just one single symbol or 2 digits per se in the Hindu Arabic for a number. So in the Hindu Arabic, we have a place value system. So we have one symbol, it's 1, 2, 3, 4, and we count. In the Babylonian, they use a place value system as well. They have 2 symbols. So they have a symbol to represent a single digit, a 1, a 2, a 3. And then it's a separate symbol to represent tens. And then they have the same symbol as 1 to represent 60. Because they're in because they count in 60 instead of in 10. So they have one symbol for 10, one symbol for 1, and then it's the same symbol for 60. In the Mayan, they also use a place value system. Though they have 3 symbols, the placement of the symbol represents the place value. In the Aztec, they have an additive symbol. They have many symbols, but you add them together to get the total of the number. So you would have more than one symbol to represent. In the Roman system, it is an additive number system. They combine symbols to signify the sum of a value. Question 3. So for question 3, we had to show the numeral 2,475 in Babylonian, Mayan, Roman, and Aztec. So Babylonians, they only have 2 symbols. So they have the sideways wedge, which looks like this, And then they have the one that is shaped like a triangle on a stick. So they have this symbol, and then they have it on its side. So these two symbols for Babylonian. But because Babylonian is in a base 60 system instead of a base 10 system, the amount of numbers that you use is different. So instead of going by 10s, we go by 60s. So for Babylonians, we would go, our first place would be 60 squares. Our second would be 60. And then our third would be the ones. So because 2,475 doesn't have 60 squared, because 60 squared is 3,600, we don't need to worry about that place value. So we would go to the next one, which is just 60. So we would divide 2,475 by 60, and that would give us 41. So then from there, we would multiply back through. So 60 times 41 is 2,460. And we would subtract that from our first number, 2,475, to get 15 left over. So it would be 41 with a remainder of 15. So in our 60s, we have 41. And in our ones place, we have 15. So it looks something like this. So to write that out in Babylonian, we would use the two symbols. And we would put a space between to signify starting a new place value. So we would do 4 of the sideways wedge. 1, 2, 3, and 4. And then 1 of the triangle on a stick. And then we would put a space. And then we would do 1 sideways wedge and 5 triangles on a stick. 3, 4, 5. So this is how 2,475 would look in Babylonian. In Mayan, they have a base 20 system instead of a base 60 or a base 10 system. And again, they have lots of different symbols, but because it's a base 20 system, we're going to do the same kind of thing. So we'll have our 20 squares, our 20s, and our ones place. So 20 squared is 400, and then 20s and ones. So because we have 2,475, it does go into 400. It does not go into 20 cubed, which is 8,000. So we'll divide 2,475 by 400. And that gives us 6. So then we multiply back through, we get 2,400. And we're left with 75. So we have 620 squares. We take our remainder and we go to the next place value. So we have 75 divided by 20, which gives us 3. Three times 20 is 60. And we will subtract to get 15. And 15 will be left in our ones. So, for the Mayans, we would have 6 20 squareds, 3 20s, and 15, not 1. 15 ones. So in order to write that in Mayan, we would have 3 rows. So in our top row, we would have our 6 20 squares, which looks like a line and a dot on top of the line. So this would be our top row to represent our 6 20 squares, or our 2,400. In our second row, we put a space, and we would have 3 dots. 3 dots represents, each dot represents 20. And 3 dots represents our 60. So then our second row would have 3 dots. And our third row would have 3 lines. Each line represents 5. So our third row would be 3 lines on top to represent 15, because each line represents 5. And so here is how we write 2,475 in Mayan. And the Aztecs use an additive system. So instead of having a place value and a base number, we're just going to use the symbols. So they have a symbol for 400. And so 400 goes into 2,475 6 times. And we know that from using the Mayans in the previous. So we know that we can use 6 of the 400 symbol, which looks like a tree with 9 branches on one side and 8 on the other. Excuse my drawings, they're really bad, but they look a little something like this. So that gives us 2,400. So then we go into their symbol for 20s. So they have, it looks like a flag for 20s, and we're going to have 3 of those. So then it looks something like this. And then we go into their symbol for 10, which is a diamond. And then their symbols for ones or singles are dots. So we'll have 5 dots. So the number 2,475 would look like this in Aztec. Lastly, we have the Romans. So the Romans had an additive system, so they just have a symbol to represent a number, and you add those symbols together. And so we would start out with their symbol for 1,000, and we would have 2 of those. So their symbol for 1,000 is an M. And then we would go to their symbol for 100, which is a C. So we'd have 4 of those. Then their symbol for 50, since we're doing 75, we would do 50, which is an L. Then their symbol for 10, for the last 20. Then the symbol for 5. And so our Roman numeral would look like this. MMCCCC For question 4, we multiplied 27 by 54 using ancient Egyptian form of doubling. So 27 and 54. And the ancient Egyptian form of doubling says that you take your 2 numbers and you create rows. So you have 2 columns, two columns, not rows. For your first number, you always start with 1 and you double. So our first number in our first column would be a 1. We would double that to get 2, that to get 4, that to get 8, that to get 16, and we would stop. We want to double until we get to a point where the number before or the number after would be larger than our starting number. So our number is 27. We want to stop at 16 because the next number up would be 32. We don't want to go over 27. So then the Egyptian rule of doubling says in our second column, we would double our starting number, our 54, the same amount of times as we did in our first column. So we do 54 108, 216, 432, and 864. So it would look like this. These would be our columns. So then from here, we would find the numbers in our columns that add to 27. So in our first column, we want to find the numbers that add to 27. So we would take 16, 8, 2, and 1. And those all add to 27. Then we want to circle the corresponding numbers in the columns. So 54, 108, 432, and 864. Our last step would be adding the numbers from the second column together to find our answer. So 54 plus 108 plus 432 plus 864. And this gives us 1,458. For our last problem in our exam, we are dividing 4 loaves of bread between 7 people using the Egyptian form of dividing. And we want to show 2 ways to do this. We want to show the hieroglyphs for both ways and the sum of the unit fractions. So, 4 loaves of bread divided by 7 people gives us 4/7. And this one was a little tricky to figure out. So 4/7 doesn't really split very well. But if we multiply the top and the bottom by 4 over 4, we get 16/28. So 4/7 is equal to 16/28. Well, the Egyptians don't have a symbol other than 1 over. So we would have to break that down to get 1 over another number. And so I know that 16/28 is a little bit bigger than a half. So I can do 1/2, which is 14/28. Well, then I still have 2/28 left, but I don't have a symbol for 2. So I would do 1/14. Because 2/28, if you divide the top and the bottom by 2, you get 1 over 14. So my final answer for this one would be 1/2 plus 1/14. If I were to draw this out, each person would start with a half. So this would be 1, 2, 3, 4, 5, 6, and 7. And then each person will also get one of these 14 pieces. And there are 14, I promise. So in our second way of showing this, if we break this down just a little bit more, we can divide 4/7 into 1/3 plus 1/6 plus 1/14. And so this would look like each person gets a 1/3, and then we would split it into a 1/6. And then each person will get one of these 14 pieces. So for the hieroglyphs, for the first one, we would have this funky symbol for a half, and then a loaf of bread over the symbol for 10, and 4 ones. So this would be the first one, the 1/2 plus 1/14. So here's 1/2, and here's 1 over 14. For the second one, we have 1 over 3, 1 over 6. So then this one would look like this: 1 over 3, 1 over 6, and 1 over 14. Thank you.